Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. So, my dear students, today I'm going to solve some numericals on mole concept in this lecture. Before starting the numericals, let me give you a bit revision about the mole concept. So, let us understand what is 1 mole again. 1 mole. What is exactly 1 mole? I have already told you that it is the unit of measurement of matter in terms of atoms and the molecules. Now, first of all, I'm writing atomic weight of an atom or gram atomic mass or gram atomic mass is called 1 mole and 6.022 into 10 to the power 23 atoms of any element is called 1 mole. The next is molecular weight of an molecule of a molecule or gram molecular mass or gram molecular mass is called 1 mole and 6.022 into 10 raised to power 23 molecules of any compound is called 1 mole. After that, formula mass of a formula unit of a formula unit of any ionic compound is called 1 mole and 6.022 into 10 raised to power 23 formula units of any ionic compound is called 1 mole. And 22.4 liters of any gas at STP is also called 1 mole. So, I am going to solve numericals of all these concepts which are interrelated to each other and also obviously to the 1 mole. So, let us start. So, first of all, my first question of first numerical is calculate the mass of one atom of silver. So let us evaluate it. I know the gram atomic mass or atomic mass of silver is 108 grams. The 108 grams, that is atomic mass of silver. It stands for, my dear, 1 mole. And in 1 mole, I know that how many atoms are there? It's 6.022 into 10 raised to power 23 atoms are there. So, round offly, 108 gram will be the collective weight of 6.022 into 10 to the power 23 atoms. So I'm mentioning it some other way, that 6.022 into 10 raised to power 23 atoms will collectively weigh 108 grams. So what will be the mass of one atom? The mass of one atom will come out to be 108 divided by 6.022 into 10 raised to power 23, and its weight comes out to be 17.9 into 10 to the power minus 23 gram. That's the mass of one atom of silver. Hopefully, my dear students, you got the first numerical. I have evaluated the mass of one atom of silver by using the mole concept. Now let's move to the next numerical. In the next numerical, the question is, calculate the mass of one molecule of carbon dioxide. Now I know mass of or molecular mass, molecular mass of CO2. It comes out to be, what's the mass of carbon? It's 12. What's the mass of oxygen? It's 16. I have to multiply this thing with 2 because oxygen were 2 in number. It comes out to be 44 grams. That's the molecular mass of carbon dioxide. This amount, the 44 gram, is called 1 mole, and in 1 mole we have 6.022 into 10 raised to the power 23 molecules. Now that means 6.022 into 10 raised to power 23 molecules of CO2 will collectively weigh 44 grams. Then one molecule will weigh, what will be the weight of one molecule? It comes out to be 44 divided by 6.022 into 10 raised to power 23, and this answer comes out to be 7.3 into 10 raised to power minus 23 grams. That's the mass of one molecule of carbon dioxide. Hopefully, my dear sons, you got the second numerical. Now let's move to the third one. The third one is saying how many number of atoms and molecules are present in 64 gram of S8 octamer. So let's calculate about it. I'm first of all calculating the molecular weight of S8, the molecular mass of S8. Now, atomic mass of sulfur, I know it's 32 grams. Then molecular mass of S8 will be equal to 32 into 8, and it comes out to be 256 grams. First of all, I got this thing. Now the molecular mass of S8, 256 grams stands for 1 mole, and 1 mole has obviously 6.022 into 10 raised to power 23 molecules. Now that means the 256 grams is mass of 6.022 into 10 raised to power 23 molecules of S8. Then the question is asking for 64 grams. What will be the mass of 64 grams? Or sorry, what will be the number of atoms in 64 grams? The 256 gram is having 6.022 10 power 23 molecules. Then 64 grams will have 6.022 into 10 raised to power 23 divided by 256 into 64. Your answer comes out to be 1.5 into 10 raised to power 23 molecules. That means 64 gram of S8 will have 1.5 into 10 raised to power 23 molecules. Now, first of all, I got the number of molecules. Now it is also asking for the number of atoms. Now, what next? One acid molecule. What next? We know that according to question, one S8 molecule. One acid molecule will have 8 sulfur atoms. 8 sulfur atoms. Then how much this amount of molecules will have sulfur atoms? Now 1.5 into 10 raised to power 23 S8 molecules will have obviously 8 into 1.5 into 10 raised to power 23 sulfur atoms. And my dear students, this answer come out to be 12.04 into 10 raised to power 23 sulfur atoms. That means this much amount of sulfur atoms. That means this much amount of sulfur atoms are present in 64 gram of S8, because question has asked the number of molecules in 64 gram of S8 and number of atoms in 64 gram of S8. What I have done over here, first of all, I have evaluated the number of molecules in 64 gram of S8. Then I knew that one S8 molecule has 8 sulfur atoms. So I have multiplied the number of molecules that are present in 64 gram of S8 into 8, and I got 12.04 into 10 to the power 23 sulfur atoms in 64 gram of S8. So this was the third numerical. Now my dear students, I am moving to the next numerical. That's numerical number 4, question number 4. Here the question is calculate the number of molecules present in 34.2 gram of cane sugar. Now, what's the molecular formula of cane sugar? It's C12H22O11. Let me evaluate its molecular weight. The molecular weight of carbon is 12. There are total 12 carbons. So 12 into 12 plus atomic weight of hydrogen is 1. Okay, I'm so sorry, let me take it again. The atomic weight, sorry, I have said the molecular weight mistakenly. The atomic weight of carbon is 12. We are having 12 atoms of carbon. So it's 12 into 12 plus atomic weight of hydrogen is 1. We are having 22 hydrogens into 22. We are having atomic weight of oxygen to be 16. We are having 11 oxygens, so into 11. So it comes out to be 342 grams. I got a 342 gram. That's the molecular weight or molecular mass of cane sugar. Now, The question is I have to evaluate the number of molecules. So 342 gram. What's this thing? It's 1 mole because molecular weight is always 1 mole, and 1 mole have 6.022 into 10 raised to the power 23 molecules. So obviously 342 gram of cane sugar will have 6.022 into 10 raised to the power 23 molecules of cane sugar. I have to evaluate the number of molecules in 34.2 gram. So 34.2 gram of cane sugar will have 6.022 into 10 raised to the power 23 divided by 342 into 34.2. Your answer comes out to be 6.022 into 10 raised to the power 22 molecules of cane sugar that are present in 34.2 gram of cane sugar. So I got the number of molecules that are present in 34.2 gram of cane sugar. Hopefully, my dear students, you got the fourth numerical. Okay, now I'm moving to the next numerical. That's numerical number 5. Question number 5. He is saying calculate the number of molecules present in 1 liter of water if density of water is 1 grams per centimeter cube. So first of all, how much volume is given in the question? Is 1 liter. So I am taking volume 1 liter. 1 liter stands for 1000 ml. The ml and the centimeter cube is the same thing. 1000 centimeter cube. The ml and centimeter cube is same thing. Now, why I have converted my volume to centimeter cube? Another question. Why I have converted my volume to centimeter cube? Because density was in centimeter cube, that's why. So let's move next. Now, how much density is given? Density of water, it is 1 grams per centimeter cube. What's the formula of density? That's mass of water divided by volume of water. That stands for 1. Now I'm putting the value of volume. Mass volume is 1000, which is given in the question. I have evaluated to the 1000 because it was a 1 liter in 1000 centimeter cube equal to 1. My mass of water, the given mass of water in numerical comes out to be 1000 grams. Now let's talk about water. H2O. What's the mass of water? Hydrogen, the atomic weight of hydrogen is 1 into 2. The atomic weight of oxygen is 16. So 16, it comes out to be 18 grams. Now 18 grams of water stands for 1 mole, and 1 mole has 6.022 into 10 raised to the power 23 molecules of water, right? So that means 18 gram of water will have 6.022 into 10 raised to the power 23 molecules. So how many molecules will be present in 1000 gram of water? So 1000 grams of water will have 6.022 into 10 raised to power 23 divided by 18 into 1000, and it comes out to be 3.34 3.34 into 10 to the power 25 molecules. So there are more methods also to solve this type of question, so I have taken the most basic one to make you understand the concept. So it was the fifth numerical. I'm moving to the next one. So in this fifth numerical, I got the number of molecules that are present in 1000 gram of water, because 1000 gram is the mass of water for 1000 ml. So let's move to the sixth numerical. Hopefully you understood the fifth numerical. Okay, let's move to the sixth one. The sixth numerical is asking calculate the number of molecules present in one drop of water having mass 0.05 gram. This is a very simple one. It's an H2O. I have just evaluated the mass of water 18 grams in the previous numerical. The molecular weight of any molecule stands for 1 mole. 1 mole has 6.022 into 10 to the power 23 molecules. That means 18 grams have 6.022 into 10 raised to the power 23 molecules. So 0.05 grams of water will have how many molecules then? It comes out to be 6.022 into 10 raised to the power 23 divided by 18 into 0.05, and this thing comes out to be 1.67 into 10 to the power 21 molecules. So this was the sixth numerical. I have evaluated the number of molecules that are present in 0.05 gram of water. So hopefully you got this numerical. Let's move to the seventh one. Now in the seventh numerical, he is saying calculate the number of moles. Now this time the question is calculate the number of moles in 392 gram of H2SO4. So first of all, H2SO4, let's calculate its molecular weight. This is H2SO4. Its molecular weight will be H2SO4. The atomic mass of hydrogen is 1. Hydrogen are 2 in number. The atomic mass of sulfur is 32 plus atomic mass of oxygen is 16 into 4. After evaluating it, I got my answer to be 98 grams. So the molecular mass of H2SO4 is 98 grams. Again, 98 grams stands for 1 mole. So 98 grams of H2SO4 makes up 1 mole. Then 392 gram of H2SO4 will make 1 divided by 98 into 392. It comes out to be 4 moles. It comes out to be 4 moles. I have one more method for this type of question. I'm writing like if you are having any question of calculating the moles, the number of moles is equal to the given weight, in question divided by molecular weight. What was the given weight over here? The given weight was 392 grams. I have taken that in numerator. Divide by molecular weight. What was the molecular weight? It was the 98. Now it's 398 divided by 98. It comes out to be 4. This method is short and the easy one. You can also do this also, but both are the same things. But both are actually the same and same things. So let's move to the next numerical. In the next numerical, the question number 8, he's saying calculate the number of moles in 44.8 liter of CO2 at STP. I have given you the relation of gases in terms of volume, that 22.4 liter of any gas at STP makes up 1 mole. Then 44.8 liter of CO2 at STP will make up 1 divided by 22.4 into 44.8. It comes up to be 2 moles. That was a very easy question, my dear students. Hopefully you understood this question. Now let's move to the next numerical. It's in question number 9. Now he is saying calculate the number of moles made by 12.044 into 10 to the power 23 molecules of O2. Now it's an O2 gas. I have already told you that 1 mole of any gas will have 6.022 into 10 raised to power 23 molecules. That means like 6.022 into 10 raised to power 23 molecules are collectively present in 1 mole. Then 12.044 into 10 raised to power 23 molecules will make up how many moles? That will be 1 divided by 6.022 into 10 to the power 23 into 12.044 into 10 raised to power 23. Your answer comes out to be 2 moles. Hopefully, my dear students, you got this question also. So let's move to the 10th numerical. Now I'm calculating number of moles in terms of number. Here I have calculated number of moles in terms of volume. In this numerical, I have calculated number of moles in terms of mass. So what's next question? He is saying calculate the number of moles in 9 gram of aluminium. I'm writing aluminium. What's the atomic mass of aluminium? It's 27 grams. 27 grams make up 1 mole. Right? Then 9 grams of aluminium will make up 1 divided by 27 into 9, and this thing comes out to be 0.33 moles. 0.33 moles. So now students, let's move to the next numerical. It's numerical number 11. Now I have taken bigger terms of mass. Calculate the number of moles in 1 metric ton of iron. So let's discuss about it. First of all, moles, I have always taken the relation of moles with mass in grams. So first of all, I have to convert my 1 metric ton into grams. Now 1 metric ton has 1000 kilograms, and 1 kilograms possess 1000 grams. That means 1 metric ton will have 1000 kilograms into 1000 grams. It comes out to be 10 raised to the power 6 grams. So I got 10 raised to the power 6 grams in 1 metric ton. So what's the atomic mass of iron? Is 55.8 gram. 55.8 gram of iron will make up 1 mole. Then 10 raised to the power 6 gram of iron will have 1 divided by 55.8 into 10 raised to the power 6. My number of moles in 10 raised to the power 6 gram of iron comes out to be 1.79 into 10 raised to the power 4 moles. So I got this much number of moles. Okay, it's all okay. So let's move to the next question. Numerical number 12. He is saying calculate number of moles in 7.9 milligram of calcium. Now again, in this thing, firstly I have to convert my milligrams to grams or grams to milligrams. Here I knew that what's the atomic mass of calcium? It's 40. What's the atomic mass of calcium? It's 40. 40 gram of calcium makes up 1 mole. Let me convert this grams to milligrams. 40 into 1000 milligrams of calcium makes up 1 mole. I have converted my grams to milligrams by multiplying 40 into 1000. So I have to evaluate the number of moles in 7.9 milligrams. Then 7.9 milligrams of calcium will have 1 divided by 40 into 1000 into 7.9, and this thing comes out to be 1.97 into 10 to the power minus 4 moles. That's my numerical number 12. I hope you got. I have calculated the number of moles in 7.9 milligram of calcium. So, and next I'm moving to the 13th numerical. In 13th numerical, the question is asking calculate number of moles in 65 microgram of carbon. This is microgram. Now 1 gram has 1000 milligrams, and it comes out to be 1 grams has 1 milligrams has 1000 micrograms. That means 1 gram has 10 raised to the power 6 micrograms. So first of all, I have converted my gram to microgram. I have given you the relation. Now what's the atomic mass of carbon? It's 12 grams. Now 12 grams of carbon makes up 1 mole, right? That means 12 into 10 raised to power 6 micrograms of carbon makes up 1 mole. Then 65 micrograms of carbon will make up 1 divided by 12 into 10 to the power 6 into 65 moles, and my final answer comes out to be 5.4 into 10 to the power minus 6. 5.4 into 10 raised to power minus 6 moles. So in this numerical, I have converted first of all gram to microgram. Then 12 gram of carbon makes up 1 mole, means 12 into 10 to the power 6 micrograms of carbon makes up 1 mole. then 65 microgram of carbon will make up 5.4 into 10 to the power minus 6 moles. So that this is my 13th numerical. We are having total 18 right now. Let's move to the ionic compound or the formula masses. Question number 14 is calculate the mass of. Now I have to calculate mass by using moles. Calculate the mass of 0.1 mole of KNO3. Now first of all I am evaluating the formula mass. It's an ionic compound, that's why word will be formula mass of KNO3. What's the atomic mass of potassium? 39. What's the atomic mass of nitrogen? 14. What's the atomic mass of oxygen? It's 16 into 3. And this answer comes out to be 101 grams. So that means this is the 1 mole. The formula mass is the 1 mole. That means the 1 mole of KNO3 will weigh 101 grams. Then 0.1 mole of KNO3 will weigh 101 into 0.1. It comes out to be 10.1 grams. So the weight of 0.1 mole of KNO3 will be 10.1 grams. In previous numericals, I was converting mass to moles. In this numerical, I have converted mole to mass. So let's move to the 15th numerical. It's in terms of volume. He's saying calculate the mass of 112 centimeter cube of H2 gas at STP. Now, what's the relationship according to mole concept between the volume and the mole? It is that 22.4 liter of hydrogen gas at STP will make up 1 mole. And what's the molecular mass of hydrogen? It comes out to be 2 grams. So that means 22.4 liter of hydrogen gas at STP will weigh 2 grams. Let me convert it to centimeter cube. So I have to convert this liter to centimeter cube by converting it to by multiplying it with 1000. It's 22400 centimeter cube. The ml and centimeter cube is the same thing of hydrogen gas at STP will weigh 2 grams. Then 112 centimeter cube of H2 gas at STP will weigh 2 divided by 22400 into 112, and it comes out to be 0.01 grams. It comes out to be 0.01 grams. So 112 centimeter cube of hydrogen will have 0.01 gram of mass. This is my 15th numerical. So my dear students, I am moving to the 16th one. In 16th, he is saying calculate the volume at STP occupied by 14 gram of nitrogen. Sorry. Now let's talk about molecular weight of nitrogen first. It's a nitrogen. The atomic mass of nitrogen is 14. The nitrogen are 2 in number. It comes out to be 28 grams. Now 28 gram, that is the molecular weight of nitrogen, is called 1 mole, and according to mole concept, the 22.4 liters of any gas at STP is called 1 mole. That means I got the relation that 28 grams of nitrogen will occupy 22.4 liters. So 14 gram will occupy 14 gram of nitrogen will occupy 22.4 divided by 28 into 14, and it comes out to be 11.2 liters at STP. So I got the volume of nitrogen, that is 11.2 liters for 14 gram of nitrogen. So my dear students, hopefully you got this numerical also. So I'm just using my mole concept, the web that I have made in the starting of this lecture. I'm just using that only, and I'm solving each and every numerical. Now I'm moving to the 17th numerical. In the 17th numerical, he is saying calculate the volume at STP occupied by 1.5 mole of CO2. Okay, CO2, the 1 mole of CO2 at STP occupies 22.4 liters. That's the mole concept. Then 1.5 mole will occupy, then 1.5 mole of CO2 at STP will occupy 22.4 into 1.5, and it comes out to be 33.75 liters. 33.75 liters. That's the volume of CO2, 33.75 liter, which 1.5 mole will occupy. So it was a very easy numerical. Now I am moving to the next one. It's question number 18th. Now he is saying calculate the volume at STP occupied by 10 to the power 21 molecules of O2 gas. Now O2 gas. Now 1 mole of O2 gas at STP, it is 22.4 liters, and mole concept also says that 1 mole has 6.022 into 10 raised to power 23 molecules of O2. So I got the relation that 6.022 into 10 raised to power 23 molecules of O2 at STP will occupy 22.4 liters. So that's according to mole concept. So 10 raised to the power 21 molecules of O2 will occupy 22.4 divided by 6.022 into 10 raised to power 23 into 10 raised to power 21, and this thing comes out to be 0.037 liters at STP. Now again I'm discussing this numerical. He is saying calculate the volume at STP occupied by 10 to the power 21 molecules of O2. I know that 1 mole of O2 will occupy the volume of 22.4 liter, which will have this much number of molecules. Now I have used this relation that 6.022 into 10 to the power 23 molecules at STP will occupy 22.4 liter. Then 10 to the power 21 molecule will occupy 22.4 divided by 6.022 into 10 to the power 23 into 10 to the power 21. My answer comes out to be 0.037 liters at STP. That means 10 raised to the power 21 molecules of O2 will occupy 0.037 liters at STP. So what was STP? It was standard temperature and pressure. So that's all for today, my dear students. I have tried to give you maximum numericals on different types of relations in the mole concept. The web which I have made in the very initials of this lecture, this thing. So hopefully you all understood today's lecture. I have given my phone number on thumbnail of this lecture. If any students want to book a paid one-to-one online class to clear doubts, contact me on my phone number. And please do try to solve the numericals of the mole concept. To now, in your homework, you have to try maximum number of numericals on the mole concept. And if you have any doubt, please do leave your doubts in the comment section of this lecture, or you can call me up. So please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.